Hey guys, let's look at our next little thing we're going to talk about. Okay, you just did that warm-up or a little while ago on probability distributions. Now we're going to compare that to another vocabulary word called a sampling distribution. Okay, this should be a review because we talked about this in the fall, but now we're comparing it to the probability distribution. So we're going to do a quick little run over it. So because a statistic, big vocabulary word, from a large sample has many possible values, assigning a probability to each value of a random variable is awkward. So we need a better method. A sampling distribution assigns probabilities as areas under a density curve, such as do y'all remember? What is it called? We studied it in great detail in the fall, the normal curve. And if y'all remember our normal curve, it follows the empirical rule of 68, 95, and 99.7. The total probability is 1 because the total area under the curve is 100%. Okay? The sampling distribution, again, I want you to learn this word so that when we say sampling distribution, I want you to go to a curve, especially the normal curve is going to be your major image that you put in your head when you hear the word sampling distribution. Okay, the sampling distribution of a statistic tells us what values the statistic takes in repeated, so we have to do this many times, samples from the same population and how often it takes those values. So it's like the little chart that you made in the last video, right, when we looked at probability distributions. But those are kind of hard to do because you have to figure every one of them out. We can use the curve so we don't have to make that big list, okay? So a new guy, P hat, right? P hat. Let's write that down so you'll know how to say it. P hat, okay? That is the answer you want. Over the total. So let's say I have 32 students in class and I said, how many of you brought me a Starbucks today? And 10 of you raise your hand. P hat would be 10 out of 32. Okay, so the number that matched what you were asking for, like how many people rolled a 6 or how many people got heads or tails or something like that. Okay, and remember your Z, remember the Z score, that takes P hat minus the mean divided by the standard deviation, and that's your Z score. So that was something very important for us, right? So let's look at an example. Again, this is kind of reviewing, but it's been a long time, so we're doing one together. So now you have a comparison of probability distribution and a sampling distribution. So an opinion poll asks a simple, that should say not an, a simple random sample of 501 teens. Generally speaking, do you approve of legal gambling or betting? Suppose that in fact exactly 50% of all teens would say yes if you asked. The poll's statisticians tell us that the sample proportion who say yes will vary in repeated samples according to the normal distribution with a mean of 0.5 and a standard deviation of about 0.022. This is a sampling distribution. Again, this is the word, vocabulary word, that's kind of what this lesson is about, to get that in your head, of the sample proportion P. Please remember, P hat means the sample proportion. Let's write that down. Okay, what is the probability that the poll will get a sample in which 52% or more say yes? Because 0.52 is not 1, 2, or 3 standard deviations away from the mean, we can't use the 68, 95, or 99.7 rule. We will use table A. That's a table that you have in your statistics notebook. If you don't have it, you can look it up online and just look for the normal distribution table, and it will be there for you. So let's figure out what all these things mean. We want to put these words to these numbers. So a sample 52% say yes. So that means we want 52% to say yes. What we want is p hat. So p hat equals 0.52. The big part about today is when we're looking at when they give you numbers, what is that? Is it p hat? Is it the mean? Is it the standard deviation? Is it z? What am I talking about? So if we say we get a sample and this is the percent of the sample that answer like we want them to, that is p hat. So now what's the mean? Let's look that up. They told us right here, in fact, 50% of all teens would say yes. So the mean equals 0.5. Now, the standard deviation was also given to us. Where is it? Standard deviation. So okay, so there we go. So now we want to look, what's the probability that 52% say yes? So I'm going to go out and ask kids, do you approve of gambling? And I want to know what are my chances that 52% or more are going to say yes. So we think about this normal. I don't know if you can see this very well on your printout. Mine kind of copied dark. So 0.5 is right here, and a standard deviation is 0.022. So this would be 5.022, and we just keep adding it on, right? 52 is going to be up above that, so let's look at what we would do. We need a z-score, since z is not just going to be 1, 2, or 3 standard deviations, so we'll figure out our z-score, and z from up here, right, is p hat minus the mean over the standard deviation. Okay, easy to do the math, use a calculator. Now, once you get a decimal for z, what do you do with that 0.91? Look up on table. So pause the video, get your table out and look that up to make sure you haven't lost that skill. So 0.911, whoops, I said 91, I wrote 99. 0.91 is, if you look it up on the table, 0.8186. What does that mean? That means 0.8186 fall to the left, which would be less than. Our question is 52 or more, and y'all know that would mean more would be reading the right side, and we know when we read the right side, we have to take 100% minus this part, so 1 minus 0.8186, and that equals 0.1814, or 18.14%, okay? And you could see it on this table a little bit. Hopefully yours is printed a little bit lighter. But that takes us back to our sampling distribution. And pay attention to how this question is worded, because you need to know, you've got all these formulas. Of course, you can write those down. There's nothing that's going to take away these formulas. But what you want to do is know what is p-hat, what is mean. So if they say the truth is 50%, would say yes, the truth, that's your mean. And then if you go and take a sample and that's 52%, that's your p-hat. So hopefully that makes sense and makes a difference in between those. Okay, so let's look at our one example. Right, I don't think there's actually a homework assignment over this. We're just going to look. Well, there's one little page. Suppose, and this again, I just want to reiterate what p-hat means. Suppose you take a simple random sample of 1,523 adults. Ask each person whether they bought a lottery ticket in the last 12 months. So again, this is a real sample. P-hat comes from a real sample, and it's the amount that gave you the answer you were asking about over the total. The proportion who say yes is the sample proportion p-hat. Imagine repeating this sample process 1,000 times. You would collect 1,000 sample proportions, one from each of the 100 samples. The histogram in figure 8.3 shows the distribution of 1,000 sample proportions when the truth about the population is that 60% have bought lottery tickets. Okay, so again, I just want to show you that right here, yes to question you asked. And that could be anything. It could be how many people went to Starbucks today? 56, then you'd have a 56 up there. If I said, how many of you are binging on Netflix 3 hours a day or more? You would answer in and say, oh, I'm binging on Netflix 3 days or more. So we will talk about that. Maybe I think I'll make up a problem. Anyway, does that make sense? I hope that makes sense. So let's do one problem together. If you will hit the pause button and use page 13 as your quote unquote homework. It says page 13, it's this. So I want you to hit the pause button and I want you to do this. And then when you're finished, come back and I'm gonna do it with you like I would in class. Right after I let the dog back in. Okay. All right, welcome back. I hope you hit the pause button. So let's do this one homework together. Therefore, I predict you all have a 100 on it. You're doing a good job of getting your homework turned in. Okay, in a recent poll of 500 registered voters, the president was given a favorable rating by 41% of the voters. Now, notice, in a recent poll, he got a 41, right? So 41 is not our mean, right? Suppose that the true proportion of adults who are given a favorable rating is 43%. So this is our mean. It's the mean because it says true proportion. The mean is really what's happening. And what we ask for is a p-hat. Okay, that gives us p-hat. In a large number of samples, the proportion who would give the president a favorable rating will be approximately normally distributed with a mean of 0.43 and a standard deviation of 0.02. So this is the mean. Now what we're going to do here is fill this in, and that will allow us to use our rule, our empirical rule. Who remembers what the empirical rule is? Raise your hand. Yes, you got it. It's the 68, 99, 95, 99.7, right? Y'all remember that? Never forget that, okay? All right, so let's fill this in. 0.43, standard deviation is 0.02, so add that on, that'd be 0.45, 0.47, 0.49, and this is going to be 0.41, 0.39, 0.37. Okay, so we've got our empirical rule filled in. Using the values given, label the normal curve at the right, well, or on top, with the mean and plus or minus standard deviation. So we're going to be 1 standard deviation, 2 standard deviations, 3 standard deviations above the mean, and this is 1, 2, or 3 standard deviations below the mean. What percent of the samples who favor the president will have a sample proportion between 39 and 47? So I'm going to do this one in yellow. 39 and 47. Well, we can see that that's within 2 standard deviations, so we know that that is 95%, right? What is the probability that p hat lies between 37 and 49? How do we figure that out, right? Well, 37 to 49 is going to be, that's going to fall in 99.7. It looks like I skipped a problem. I accidentally read D. I need to go back and read C. Okay, so C says, what percent of the samples who favor the president will have a sample proportion of less than 41? So that's this part, correct? So we know that from here up is 50%, right? And if you remember back, we know that this is how much this, between these two is 68, so that's 34. So this part right here is going to be 50 minus the 34. So that's going to be 16%, right? Remember, on this one, we are strictly using the guidelines of our empirical rule. What is the probability that p hat does not lie between 37 and 49? Well, it's 99.7% going to be in between. So what's not going to be in between? Well, 100% minus 99.7, so 0.3%. Again, this is review. You can look up empirical formula and stuff that we've done before if you've forgotten some of this. But this is, of all the things I want you to take away from statistics, being good with your normal curve, your normal distribution, and understanding the empirical rule is one of the big boulders in the rocks of statistics. So would you be surprised if the sample proportion of those who could give the president a favorable rating was 55%? Well, let's look. We're at 43 and we're going up to, you guys know that 3 standard deviations away is hard to get, and above 3 standard deviations is extremely difficult to get right. That's way, way, way down there in the percent, because 99.7 fall in between here. So we're talking 0.15%, very low if you get above 0.49, and this is asking for 0.55. So would you be surprised? Yes. 55% would be, matter of fact, let's see how far that would be. So 49 plus 0.02 would be 0.51. And after that would come 0.53, and then would be 0.55, because we keep adding the 0.02 on. So that would be 1, 2, 3, 4, 5, 6. That would be 6 standard deviations above the mean. Okay. Its probability would be extremely low. And I just want to go through real quick. That's it. All of our notes. We're starting something brand new next time. So I just want to go through here with you and remember that 68%, let me draw my little, 68% fall within one standard deviation. So that means I've got 34 and 34%, right? Because this is 68. And then if we go to here, it's 95%. So if I take 95% minus the 68 that I've already used up here, right? That's 68. So I take 95 minus 68. That tells me what's left for these spots. I got to divide it by 2 because half goes here and half goes here. That leaves 13.5, 13.5, right? And then if I go to 3 standard deviations, I've already used up 95%. I know that this mark would be 99.7, so that leaves 4.7%. And if I divide that by 2, it gives me 2.35 on each side. Remember these numbers. And then if I go above that, let's say this whole thing is 100. Well, I've already used up 99.7%, so that leaves 0.3%. So that's 0.15 and 0.15 left, right? So this is 1 SD, 2 SD, that's standard deviation, 3 standard deviations. I should use a symbol, but I think you'll remember this better. This is standard deviations below the mean. So y'all know that to get above 3 standard deviations, you're at 0.15%, which is very, very tiny. Okay, so this finishes your first day of the week, and we'll start brand new stuff on our next day. Have a great day.